So for number 11, it asks us to identify the vertex and x-intercepts for each equation. And both of these, since they have the parentheses and then that's being squared, they're both in graphing form. So in graphing form, the vertex is actually really simple to identify. To figure out the vertex, you just look at the number in the parentheses after the x, and the opposite of that number will be the x-coordinate for the vertex. So that means that my vertex for A will be at -4, will be its x-coordinate. And then this number that comes after the parentheses, whatever that is the y-coordinate of the vertex. So it's always going to be opposite of this one is the x-coordinate. Whatever this one is, that's the y-coordinate. So this one's vertex is at -4, -9. And then we're also supposed to find the x-intercepts. So anytime you want to find x-intercepts, you start by making y 0, because the x-intercepts are on the x-axis where y is 0. So I'm going to replace the y in the equation with 0. And then I just need to solve this equation for x. So I'm going to solve it by undoing. So whenever you're solving and you're undoing, you do PEMDAS backward. So you're doing like SADMEP. So that means the first thing we want to undo is addition or subtraction. We can't undo this addition or subtraction in the parentheses because things in the parentheses happen last when you're undoing. So I'm going to undo this -9 by adding 9 to each side. So then I have this. Then I'm going to undo my exponent, would be before the parentheses. So to undo something being squared, the opposite of a square is a square root. So I'm going to take the square root of each side. So 9 has 2 square roots. Every positive number actually has 2 square roots. So square root of 9 we know is 3, but actually there's also -3 is the other square root of 9. So I'm going to actually have 2 equations, one where the square root of 9 is 3, one where it's -3. And then for the right side of the equation, the x plus 4 was being squared, but then we took the square root of it, and the square root just undoes the square, so we just have the x plus 4 now. And we have the 2 separate equations, one with the 3, one with the -3. Right side is x plus 4 for both of them. And then we just solve those two, and that gives us our x-intercept. So I get that x is -1 or -7. So those are my 2 x-intercepts that parabola would have. So we're going to do the same process now for B. So first, to find the vertex, like we did on the other one, x-coordinate is always the opposite of this number that's in here with the x. So that would be +2. And then this number out here is the y-coordinate. So that would be -5. And then to get x-intercepts, I gotta put in 0 for y first. And then I just want to solve. So I'm going to undo the subtraction by adding 5 to each side. Then I'm going to undo my exponent, my square, by taking the square root of each side. Now this time when I do that, I want to take the square root of 5. And we don't want half of 5, so it's not 2.5. We want a number that if we multiplied it by itself, we would get 5. That's not a whole number, and you can't really figure it out in your head. So you need a calculator in order to do that. So real quickly, sorry, I'm just grabbing my calculator. I'm going to find the square root of 5. And it is, I'm going to round to 2 places after the decimal. So it's about 2.24. And again, there are 2 square roots of 5. So I'm going to have 2.24. Then I'm going to do another equation with the other square root of 5, which would just be the negative of the same number. So -2.24. And then square root undoes the square, so I just have x minus 2 on the right side. And then I just solve both of those to get my 2 x-intercepts for this one. So I get 4.24 and -0.24. 2, 4 as the x-intercepts for that one.